This is my geometry course. Today we're going to continue to learn circles, specifically angle and segment relationships in circles. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We're going to start with angle relationships, and we're first going to learn inscribed angles. Now this is an inscribed angle because the vertex of the angle is on the circle. It's not outside the circle. It's not inside the circle. The vertex is on the circle. So that's called an inscribed angle. And the sides of the angles are chords. Now, we're going to learn this theorem as the first thing today, the inscribed angle theorem. So this theorem says that the measure of an inscribed angle is equal to the measure of the corresponding arc divided by 2. This is also called the intercepted arc. So again, if you draw an inscribed angle, that's what this thing is here, this angle here, the measure of that angle is equal to the measure of the intercepted arc, or the corresponding arc, the measure of the corresponding arc divided by 2. That's what this tells us. So you can go ahead and get screenshots of that information if you want, or take a picture with your phone, because we're going to use all that in the problems here. So if you didn't understand what that meant, that's okay. You'll see when we do practice problems. So we want to find the measure of angle E. The measure of angle E is equal to, this measure here is equal to the measure of the corresponding arc, which is 118, divided by 2. So that would be 59 degrees. (118 divided by 2). So as you can see, it's pretty easy. Let's find the measure of angle J now in number 2. Measure of angle J is equal to, this measure here is equal to the measure of the corresponding arc, or the intercepted arc, divided by 2. So the measure of angle J is equal to 15.5 degrees. So why don't you try number 3, and when you come back, we'll do it together. All right, we're back. The measure of angle N is equal to the measure of the corresponding arc, or intercepted arc, divided by 2. So the measure of angle N is equal to whatever 176 divided by 2 is, and you can use your calculator if you need to. 176 divided by 2 is equal to 88 degrees. So if you got 88 degrees, good job. So go ahead and try number 4, and when you come back, we'll do it together. All right, we're back. The measure of angle R is equal to the measure of the corresponding arc divided by 2. So the measure of angle R is equal to 57 divided by 2. Again, you can use your calculator if you need to, and that would be 28.5 degrees. So if you got that answer, good job. So now we're going backwards in number 5. Number 5, you're given the measure of the inscribed angle. Okay, you're given this measure here, and you're asked to find the arc measure in these next problems. So that's going to be 30. We're going backwards. We're given this number. We're looking for that number before, and that's equal to the measure of the corresponding or intercepted arc divided by 2. So now we just have to do some algebra. So basically what we're just going to do is multiply both sides by 2, because we have an equation with fractions. To get rid of the fraction, you just multiply by the lowest common denominator, and you can see that the lowest common multiple of 1 and 2 would just be 2. So you multiply both sides by 2, and we get 68 degrees is equal to the measure of arc MP. So again, you're just going backwards. In these problems, we were taking the arc and dividing by 2, and now we're taking the inscribed angle and multiplying it by 2 to get the arc measure. Number 6, again, we have the inscribed angle. The inscribed angle is equal to the corresponding arc measure divided by 2. So now we just multiply both sides by 2, and we get 170 degrees is equal to the measure of arc DE. So why don't you try one of those problems? Go ahead and try number 7 on the bottom left, and when you come back, we'll do it together. All right, we're back. So the measure of the inscribed angle is equal to the measure of the corresponding arc, or intercepted arc, divided by 2. Multiply both sides by 2, and we get 92 degrees is equal to the measure of the intercepted arc. Again, you can call it intercepted arc, or you can call it corresponding arc, whatever. So if you got that answer, good job. Try number 8, and when you come back, we'll do it together. All right, we're back. So the measure of the inscribed angle is equal to the measure of the corresponding arc divided by 2. Multiply both sides by 2, and we get 110 degrees is the measure of the corresponding arc. So if you got that answer, good job. I'm going to draw that a little better there. Now, if you're thinking these problems are easy, you're right, but you still have to learn them. You know, doing these problems helps you to remember the formula. So on the first problems, we plugged in this number to find this number. In the second problems, we plugged in this number to find this number. So we're just learning how to use this basic inscribed angle theorem. All right, number 9, M is the center. So find the measure of arc LG. So these are problems that are just utilizing the same theorem. They're the same equation from the theorem. So we're looking for the measure of arc LG, which is this arc here. And we don't know what that arc is. We don't have a method for finding that arc. We do know how to find this arc, though. So let's go ahead and find that arc, and then I'll kind of show you what's going to happen here. So we know that the inscribed angle, because this is an inscribed angle here. That's what this is. It's an inscribed angle. We know that's an inscribed angle. So 43, the inscribed angle, is equal to the corresponding arc measure, which is AG, divided by 2. So multiply both sides by 2, and we get 86 degrees is equal to the measure of arc AG. So we just did the same problem that we did in the previous ones. We just found, we were given the inscribed angle, we found this arc. We don't want that arc. We want this arc measure here. So how do we do it? Well, the key is M is the center. So what that means, because this chord goes through the center, that means this whole arc from here all the way to here is 180 degrees. It's half the circle. Remember, a whole arc is 360. It's just defined that way. So if we know that this entire arc is 180, and we know from the arc addition postulate that this arc plus this arc must equal the total arc, it's pretty obvious what's going to happen here. The measure of arc LG is equal to 180 minus the measure of arc AG, which is 86 degrees. And that equals 94 degrees. So let me move this over a little bit. So again, just to be clear what we did here, we took 180 and we subtracted this arc, AG, and that gave us this arc, the measure of this arc, LG. So it's 94 degrees. So that's just kind of a specialty problem. So why don't you try a problem like that? Number 10 is pretty much the same thing. Go ahead and attempt number 10, and when you come back, we'll do it together. All right, we're back. L is the center, so, well, first let's go ahead and find this arc measure here. So we know the inscribed angle measure is equal to the corresponding arc measure divided by 2. Multiply both sides by 2, and you get 36 degrees. So we just found that the measure of arc RT is 36 degrees. That's this arc here. So now we just subtract that from 180, and that'll give us this arc, the measure of arc SR. So the measure of arc SR is equal to 180 minus 36. So the measure of arc SR is equal to whatever that ends up being, and you can use your calculator if you want. 180 minus 36, which is 144 degrees. So if you got 144 degrees, good job. Be sure to write degrees. So again, these are just specialty problems using the inscribed angle theorem. Those are special because one of the sides of the inscribed angle is actually a diameter. So those are special problems. All right, so now we have 2 inscribed angles. So this is going to get a little tricky, so I'm going to draw these angles. We have one inscribed angle here, and we have another inscribed angle here. Let me get a bigger pen. Whoops, sorry. So we have 2 inscribed angles. Do you see those 2 inscribed angles? Now, what you should notice about these 2 inscribed angles is that they both have the same intercepted arc. Both of their intercepted arcs are BC. So what that means is that because they have the same intercepted arc, the actual inscribed angles must be equal also. Now we could come up with a theorem for that, but it's so obvious that I don't really think I need to write a theorem. So the measure of angle A is equal to the measure of angle D. And you don't really have to write that, but I'm just showing you, just to show some work there. So measure of angle A is 20 degrees. So pretty simple. All right, so try number 12. Again, hopefully you understand the basic concept. Because they have the same intercepted arc, they must have the same angle measure. So try number 12, and when you come back, we'll do it together. All right, we're back. So in case you're having trouble seeing this, because I know it is kind of weird to have to visualize that, but this is one inscribed angle, and this is another inscribed angle. So because they observe that they both have the same intercepted arc. So if angle G is 67 degrees, that means that angle F, or the measure of angle F, must also be 67 degrees. So again, those were pretty easy. So if you got that answer, good job. Just so if you look back at this, I should probably do an extra step there. I guess I can keep that. I'm just going to do one extra step just to make sure you understand what's going on here. So measure of angle F is equal to measure of angle G. All right, on to number 13. So now we just have some more specialty problems. Again, all these problems are just helping you to learn how to use this inscribed angle theorem. That's all we're doing. Number 13, we have 2 inscribed angles, and it says find the measure of angle J and K. So this is the measure of angle J and K right here. So what we're going to do is we're going to observe this triangle here, and we're going to use the triangle sum theorem to find this angle. The problem is we can't use the triangle sum theorem because we don't know this angle. But actually we can easily find that angle because we know that this intercepted arc is 60 degrees. So that means that the measure of angle K is equal to 60 divided by 2. So the measure of angle K is equal to 30 degrees. So now we have this angle is 30 degrees. So because we have that angle, we can now use the triangle sum theorem. So the measure of angle J and K is equal to 180 minus 30 degrees minus 45. And whatever that ends up being, that is our answer. So I'm going to move this up a little bit. Measure of angle J and K is equal to, and you can use the calculator for that if you need to, 180 minus 30 equals minus 45 equals 105, so 105 degrees. So again, we're just doing more and more complicated problems to help you learn the inscribed angle theorem. So I want you to try number 14 and 15. 14 and 15 are kind of just variations of the same problem we just did. They're puzzles. And if you understand the inscribed angle theorem, you can solve the puzzle. If you get stuck, that's okay, but I want you to give an honest attempt for number 14, and when you come back, we'll do it together. All right, we're back. So we want the measure of angle DEB. So DEB is this angle here. And we'd like to use the triangle sum theorem, but the problem is we don't have any of the angles inside the triangle. We have none. Over here, we at least had one, but in this problem, we don't have any. But we do have two intercepted arcs, so those are going to help us find the angles that we need to find angle DEB. So let's deal with 122. This is the intercepted arc, or the corresponding arc of this angle, you see. So if I were to draw that out, you see this is the intercepted arc. So that means we can find angle B just by dividing 122 by 2. That's this angle here. So the measure of angle B is equal to 122 divided by 2. And that would be, I think that would be 61 degrees. Okay, so now we have this angle here is 61. We need one more angle in order to find angle DEB. So now we're going to use 28 degrees. Now I'm going to draw an inscribed angle. You see this inscribed angle here? You can see the intercepted arc is 28 degrees, so we just divide that by 2 and we get angle D. So that's the other angle we need to use the triangle sum theorem. So the measure of angle D is equal to 28 divided by 2, which is equal to 14 degrees. And so the final angle that we're looking for, the measure of angle DEB, is equal to, we can use the triangle sum theorem now, so 180 minus 61 minus 14. And whatever that ends up being, that's our answer. So the measure of angle DEB is equal to, and you can use a calculator if you want, 180 minus 61 equals minus 14 equals 105. So it just happened to be the exact answer we got for number 13. That was just a coincidence. So if you got that answer, good job. If you got stuck, that's okay. These are puzzle problems. So if you can solve the puzzle, great. If you can't, that's okay. You'll get the next one. So try number 15. That's another puzzle problem using the idea of the inscribed angle theorem. So try at 15, and when you come back, we'll do it together. All right, we're back. So the measure of angle GJH, that's this angle here. We're going to find this angle. We know this angle because this inscribed angle and this inscribed angle, they both have the same intercepted arc. That's GH. GH here. So because they both have the same intercepted arc, that means the inscribed angles must be the same. So if this is 22 here, then this must be 22 also. So if this is 22, then we can easily find this angle with the triangle sum theorem. The measure of angle GJF is equal to 180 minus 78 minus 22. So again, we're just using the triangle sum theorem. Get out our calculator for that. 180 minus 78 equals minus 22 equals 80 degrees. So this angle here equals 80 degrees. So if this angle equals 80 degrees, then we can just subtract that from 180 to get this angle, because we have a straight line segment here, so this angle plus this angle must be 180 degrees because they form a linear pair. So we can say the measure of angle GJH is equal to 180 minus 80. So measure of angle GJH is equal to 100 degrees. If you got that one, good job. If you didn't get it, that's okay. Again, with more practice, you're going to get these down. Okay, time for number 16. B is the center, find X. Now notice we have a triangle in here, so we actually have three inscribed angles. We have this inscribed angle, and we have this inscribed angle, and we have this inscribed angle. Now, I want you to notice something. First of all, we have this inscribed angle is 59, and we're looking for this inscribed angle. But we notice that the intercepted arc for this inscribed angle just happens to be right on the endpoints of a diameter. And how do we know that's a diameter? Because B is the center, and that chord is going right through the center. So what that means is that this arc here must be 180 degrees. It's half of the circle. That's just the definition of arc measure. Again, a total arc measure is 360. Half of arc measure would be 180. So what that means is that this angle down here must be half of 180, which means it's a 90-degree angle. So this is a right triangle. So the measure of or X is equal to 180 minus 59. We're just using the triangle sum theorem, minus 90 degrees. So X is just 180 minus these two angles, just using the triangle sum theorem. So that would be 31 degrees. Okay, so why don't you try a problem like that, and when you come back, we'll do it together. All right, we're back. So again, this is a diameter, so this arc measure must be 180 degrees, which means that this must be a 90-degree angle. So y is just equal to 180 minus 90 minus 47. If we do that in the calculator, 180 minus 90 equals minus 47 equals 43 degrees. So y is equal to 43 degrees. If you got 43, good job. So continuing on here with the inscribed angle theorem, we're just doing practice problems. So number 18, D is the center of the circle. Find the measure of arc AB. This arc here, you see. And to find that, we need to find this inscribed angle here. There may be multiple ways to do this, but I'm just going to do it this way. So we're going to find this angle here, and then we're just going to use, we observe that this is a diameter, which means that this angle must be 90 again, because this arc, you know, if you have the corresponding, if you have the inscribed angle there, you see that this arc is 180, therefore that angle inside is 90 degrees. So I'm going to use the triangle sum theorem. I'm going to first find the measure of angle C. So 180 minus 90 minus 70 gives us the measure of angle C, and that would be 20 degrees. So we now have the measure of this angle here, so now we can easily find the measure of this corresponding arc, because that's a corresponding arc. So again, we're not finding this side, we're not finding that side, we're finding this arc measure. So if we treat this as an inscribed angle, and we know this angle is 20, then that means this arc measure must be double that, using the inscribed angle theorem. So the measure of arc AB is equal to 2 times 20. Therefore, the measure of arc AB is 40 degrees. So on to number 19. I want you to try a problem like that. Go ahead and try number 19, and when you come back, we'll do it together. All right, we're back. So again, this angle must be 90 for all the same reasons we talked about. So we can find the measure of angle G by subtracting 90 from 180 and also 68 from 180. And that would give us 22 degrees. So the measure of angle G is 22 degrees. And now that we have angle G, we can easily find the arc measure, because that's the corresponding arc measure of the inscribed angle G. So that would just be double G. So the measure of arc DF is equal to 2 times 22 degrees. So that would be 44 degrees. So if you got that one, good job. If you didn't, that's okay. Now you know how to do that problem. So now we have just a few more problems with the inscribed angle theorem here. You can see that we now have quadrilaterals because we have actually 4 inscribed angles. We have one there, that's measure of angle A, or that's angle A itself, and then we have angle D is an inscribed angle, and then we have angle C, and so on and so forth. We have 4 total. So this is going to be kind of a challenge problem, I guess. We want to find the measure of arc ADC. So this is the easy part, arc ADC. Now if you consider angle B to be an inscribed angle, which it is, then obviously the corresponding arc would be here. So we can easily find that just by doubling 88. So 88 is equal to the measure of arc ADC divided by 2. So just multiply both sides by 2, and we get 176 degrees is equal to the measure of arc ADC. So that was easy. That's not the hard part. The next part, we have to find the measure of angle D, this angle here, you see. Now, in order to find that angle, the measure of that inscribed angle, we need the measure of the corresponding arc. And that corresponding arc would be here. Problem is, we don't have that arc measure. Okay, we don't have that arc measure. We have this arc measure. But we can easily find the orange by just taking 360, because that's the total rotation is 360, and just subtracting the arc, the yellow arc, and that'll give us the orange arc. So the measure of and once we find the orange arc, then we can use that to find angle D. So I know that seems kind of complicated, but it's just basic stuff. So this is kind of a 2-part problem. I'm going to put Roman numeral 1 here. That's part 1, and then part 2. So, like I said, the measure of arc ABC is equal to 360, the total minus the measure of arc ADC, which we found is 176. So the measure of arc ABC is equal to, and you can do that in your calculator if you want, 360 minus 176 is equal to 184 degrees. So what did we just find? We just found the orange arc ABC by subtracting this arc from 360, because again the total rotation is 360. So measure of arc ABC is 184. So you might be thinking, I don't get it. Who cares? Well, now that we have that arc, we can go backwards and find this intercepted or inscribed angle. Again, in case you're lost here, we have this inscribed angle. We just found the intercepted arc, so we just divide by 2 and get the measure of angle D. Sometimes the hardest parts of these problems is just avoiding all of the other, segments or chords inside the circle, so you can see what's going on. So the measure of angle D is equal to 184 divided by 2. So the measure of angle D is equal to 92 degrees. So I want you to try a problem like that. Go ahead and try number 21. And if you get stuck, that's okay, but give it an honest attempt. And when you come back, we'll do it together. All right, we're back. So we can find the measure of arc SFT pretty easily. That's the easy part. The measure of arc SFT. Well, first of all, we know that the inscribed angle here. See, this is an inscribed angle. That angle measure there is equal to the corresponding arc measure divided by 2. So it's equal to the measure of arc SFT divided by 2. Multiply both sides by 2, and you get 190 degrees. So the measure of arc SFT, this arc here is 190 degrees. So that was the easy part. So now that we need to find the measure of angle F, and to do that, we're going to find this this corresponding arc measure here, the intercepted arc. So we're going to subtract this arc from 360 to find that arc. So the measure of arc SLT, we probably don't need 3-letter notation for that, but I'm just going to write it so we don't get confused. So the measure of arc SLT is equal to 360 minus 190. And we can do that in the calculator. 360 minus 190 is 170. So SLT is 170, and we can use that arc to find the corresponding inscribed angle, the measure of that angle, which is F, which is what we're looking for. So measure of angle F, the inscribed angle, is equal to the corresponding arc, 170 degrees divided by 2. And the final answer is whatever 170 divided by 2 is, that's 85 degrees. So if you got that answer, good job. If you got stuck, that's okay. So on to 22. Now, before we go to 22, you see in 22 we have more quadrilaterals there. But I want you to see, do you notice that we know angle B is 88, and we know angle D, we found that down at the bottom, is 92 degrees. And if you notice, these two angles are actually supplementary. And we know this angle is 95, and we found the opposite angle here is 85. Those are supplementary also. If you add those up, it's 180 degrees. So it turns out that opposite angles are supplementary. So it says here, we want to find measure of angle A. That's an opposite angle. So it's just going to be 180 minus 105. Now you could come up with a theorem for that, but I really don't want to write any more theorems. I don't think that's really necessary. If you don't remember that, you can just do the math and figure it out using the same methods we used over here in these problems. Some people might say, well, I want a theorem for that because I'm not going to remember it. Well, the only problem with that is now you have another theorem you have to memorize. So that was part 1 of that problem. I probably should have used Roman numerals on the previous problem. And of course, measure of angle C, you just use the same situation. It's just 180 minus 93, because again, these are opposite angles, and like I said, they turn out to be supplementary. So 180 degrees minus 93 is 87 degrees. And so there you go. As long as you can remember that if you have a quadrilateral inside or inscribed in a circle, then the opposite angles are supplementary. So why don't you try number 23, and when you come back, we'll do it together. All right, we're back. So the measure of angle H is equal to 180 minus 90, because the opposite angle is 90. And so obviously the measure of angle H would just be 90 degrees. So it should look 90 degrees, and you can see it looks pretty close there. Well, it is supposed to be 90 degrees. My drawing is not exactly 100% accurate every time. So now step 2, we just do the same thing with measure of angle G. That's equal to 180 minus 92. So measure of angle G is equal to whatever 180 minus 92 is. And we get 88 degrees. So if you got that answer, good job. And again, we're just taking the inscribed angle theorem to the extremes here. We could write harder problems, but those are a good representation of what you're going to see. So now we're going to learn our second theorem of the day, the secant-tangent angle theorem. So this theorem just tells us that if you have if the vertex of an angle is on a circle, so the vertex is still on the circle like the previous problems we did in the inscribed angle theorem, and the vertex is on the circle, and one of the sides of the angle is a secant. Remember, secant means it intersects the circle twice, and the other side of the angle is a tangent, meaning it intersects only once. Then the measure of that angle is equal to the measure of the intercepted arc divided by 2. So it's kind of the same thing that we already did. So we just take this arc measure, divide it by 2, and that gives us this angle. So it's really not, it's nothing big. If you want to get a screenshot or a picture of your phone, because we're going to use this as we go along, you can do that. So we want the measure of angle ABC. That's just going to be 162 divided by 2. And I guess I could have just called it measure of angle B on that one. So that would be 81 degrees. And for number 25, we're going backwards. Now we have the actual angle measure, and we're looking for the measure of the intercepted arc. So we know 135 is equal to the measure of the intercepted arc, which is DFE, and divided by 2. So then we just multiply both sides by 2, and we get 270 degrees is equal to the measure of arc DFE, and that is the answer. All right, now notice that in the previous problems we had rays as sides of the angle, rays as the sides of the angle, but you can also have a chord, and you can have a secant line. It's the same situation. So just be aware of that. We're looking for measure of angle 1, this angle here. If we had this arc measure, we could just divide by 2 and find that immediately. But we have only this arc measure. So we're going to divide 166 by 2 to get this angle, and then we'll just subtract the measure of angle 2 from 180, and that'll give us the measure of angle 1. So let me put a divider here. So the measure of angle 2 is equal to 166 divided by 2, and that would be equal to, we can get our calculator out, 166 divided by 2 is equal to 83 degrees. And now the measure of angle 1 is 180 minus 83 degrees. So measure of angle 1 is equal to 97 degrees. One more of these problems before you try one on your own. We're looking for the measure of arc SM. So that is this arc here. But we don't. If we had this angle, we could just double it to find this arc. But the problem is we don't have that angle. We have this angle. So there's a lot of different ways you could do this. One way, I'm just going to take 180 and subtract 100, and that'll give you this is 80, and then multiply it by 2, and that'll give us this arc, which is 160. Did I say 180? I meant 80. So the measure of angle SML is equal to 180 minus 100. So that would be 80 degrees. And then the measure of arc SM is equal to 2 times 80. So the measure of arc SM is 160 degrees. So those are just some example problems of this secant-tangent theorem. Okay, so now it's time for you to try. I'm going to leave that theorem in the window along with those practice problems. I want you to try number 28, and when you come back, we'll do it together. All right, we're back. Let me put a divider here. The measure of angle 2 is equal to the corresponding arc, or intercepted arc measure, divided by 2. So the measure of angle 2 is just 170 divided by 2, which is 85 degrees. So if you got that answer, good job. Try number 29, and when you come back, we'll do it together. All right, we're back. Now we're just going backwards. We know that the angle is equal to the intercepted arc measure, divided by 2. And so multiply both sides by 2, and we get 194 degrees is equal to the measure of arc TJC. So if you got that answer, good job. All right, go ahead and try number 30, and when you come back, we'll do it together. All right, we're back. So, there's a couple of different ways probably we could do this. We can find this angle by dividing this intercepted arc by 2, and then we can just subtract that from 180. I guess that's the way I'll do it. So I'm going to name this angle angle 2, and so the measure of angle 2 is equal to 260 divided by 2. So the measure of angle 2 is equal to 130 degrees. And the measure of angle 3 is just equal to 180 minus 130, and that would equal 50 degrees. So if you got that one right, good job. There are different ways to do this, so you may not have done it exactly the same way, but if you got the right answer, good job. Try number 31, and when you come back, we'll do it together. All right, we're back. We're looking for this arc, and I'm going to find this arc first. So we know that angle is equal to the measure of the intercepted arc divided by 2. Multiply both sides by 2, and we see that the measure of that intercepted arc is 110 degrees. Now to find the measure of arc MLN, we just subtract that from 360. And so the measure of arc MLN is equal to 250 degrees. So if you got that answer, good job. All right, on to another theorem. We're still dealing with angles. So we're going to go to angles with the vertices outside circles. So the vertex of these angles are outside the circles. That's what we're dealing with now. So what this theorem tells us is that this intercepted arc measure minus this intercepted arc measure divided by 2 is equal to this angle here. That's all that's saying. It doesn't matter if you have secants or tangents or a secant and a tangent for the sides of the angles. This theorem works. So, for example, in this case, the measure of this intercepted arc minus the measure of this intercepted arc divided by 2 is equal to this angle measure. You have this intercepted arc measure, and you want to subtract this intercepted arc from that arc measure, and divide it by 2, and you get this angle here. So this looks pretty complicated, but it's really not too bad. You can get a screenshot of that if you want. And let's try problem number 32. So the measure of angle A is equal to 113 minus 35 divided by 2. And you just crunch the numbers on that, and you're done. So it's pretty easy. 113 minus 35 equals 78 divided by 2, and we get 39. I should probably show steps on that, I guess. So 78 over 2, measure of angle A is equal to 39 degrees. So pretty simple. So let's try another one of those problems. The measure of angle B is equal to 241 minus 120 over 2. And we get 241 minus 120 is 121. And then divide that by 2. We get 60.5 degrees. So as you can see, it's pretty easy. So let's try one more of these before you try one on your own. In this case, we had 2 tangents, and in this case, we had 2 secants. Now we have a secant and a tangent, but it's pretty much the same concept. So the measure of angle C is equal to 200 minus 38 divided by 2. And 200 minus 38 is 162. And divide that by 2, and we get 81 degrees. So measure of angle C is 81 degrees. So again, 3 situations, but it's really the same concept. So I want you to try number 35, and when you come back, we'll do it together. All right, we're back. The measure of angle D is equal to 252 minus 108 over 2. And do the math on that. 252 minus 108 is 144. And finally, the measure of angle D is equal to 144 divided by 2, which is 72 degrees. So if you got that answer, good job. Go ahead and try number 36, and when you come back, we'll do it together. All right, we're back. The measure of angle E is equal to 84. And by the way, this is two tangents. Now we have two secants. Measure of 84 minus 26 divided by 2. I'm going to move this over a little bit. So 84 minus 26 equals 58. And 58 divided by 2 is 29. I don't think I have to keep showing each step there. So 29 degrees. Try 37, and when you come back, we'll do it together. All right, we're back. The measure of angle F is equal to 145 minus 30 over 2. 145 minus 30 is 115. And 115 divided by 2 is 57.5. So we got that answer. Good job. So again, we're using this angle vertices outside circles theorem. And on to number 38. Now we're just going to try some problems that mix things up and give you different numbers. So in the previous problems, we were looking for this angle, but we have this angle in this problem. Now we're looking for this arc. So we know that that angle is equal to the difference of those arcs divided by 2. So now we just have to solve that algebraic equation. So multiply both sides by 2. I'm not going to show all the steps because, it would take a lot of room. And we're going to subtract 156 from both sides. So we get 80 minus 156 is negative 76. Divide both sides by negative 1, and we get x is equal to 76 degrees. So same problem we were doing before, except we're given different numbers to plug in. Let's see here. Now, again, that angle 50, we know it equals the difference of the intercepted arcs divided by 2. Multiply both sides by 2, and you get 100 is equal to y minus 87. Add 87 to both sides, and you get 187 degrees for y. So I want you to try number 40, and when you come back, we'll do it together. All right, we're back. So we know that angle outside the circle, that angle measure must be equal to the difference of the intercepted arcs divided by 2. Multiply both sides by 2, and we get 110 is equal to 270 minus z. And subtract 270 from both sides. So 110 minus 270 is negative 160. Divide both sides by negative 1, and we see that z is equal to 160 degrees. And make sure you put your degree symbol. So if you got that answer, good job. Why don't you try number 41, and when you come back, we'll do it together. All right, we're back. The angle is equal to b minus 86 over 2. Multiply both sides by 2, and we get 98 is equal to b minus 86. And if we add 86 to both sides, we get 184. So b is equal to 184 degrees. If you got that answer, good job. All right, now we're going to the angle vertices inside circles theorem. So just to review here, we're talking about angles. We haven't got to segments yet. We learned inscribed angles, the inscribed angle theorem, and we learned the secant-tangent theorem, secant-tangent angle theorem, and the angle vertices outside circles theorem. So we dealt with angles on the circle and outside the circle, and now we're dealing with angles inside the circle. So what this theorem says is that if you have two chords inside a circle, the angle, and you can talk about any one of those four angles, but we're going to talk about this one. This angle is equal to the sum of the intercepted arcs divided by 2. So if you want this angle, you just take this arc measure here and add it to this arc measure here, and you divide that by 2. Now, if you want, let's say that you wanted this angle measure here, then you would take this arc measure and add this arc measure and divide by 2, and that would give you that angle measure. And same thing with the other ones. And by the way, if you get this measure, obviously we can find this measure because it's a vertical angle pair. But we shouldn't get into that now. All right, so you can take a picture with your phone, so you can have this in front of you as we do these problems if you want. So the measure of angle 1 is equal to 170 plus 75 divided by 2, and we just have to crunch the numbers, and that'll be the answer. So 170 plus 75 is equal to 245, and just divide that by 2, and we get 122.5 degrees. So you don't really have to show this intermediate step. I'm just doing that just to be absolutely sure that students will know what is going on here. So let's try this again. So we want the measure of angle 2. That's just the sum of the intercepted arc measures divided by 2. So the measure of angle 2 is equal to 39 plus 35 is 74. And 74 divided by 2 is 37 degrees. So the measure of angle 2 is 37 degrees. And so now it's time for you to try. I'm going to leave that whole theorem in the window there. Try number 44, and when you come back, we'll do it together. All right, we're back. The measure of angle 3 is equal to 42 plus 87 divided by 2. And 42 plus 87 is 129. Divided by 2 is 64.5. So if you got that answer, good job. Don't be afraid to use your calculator on these problems. So try number 45, and when you come back, we'll do it together. All right, we're back. Measure of angle 4 is equal to 130 plus 71 divided by 2. So 130 plus 71 is 201. And that would be 100.5 degrees. So if you got that answer, good job. Okay, so now we're just doing some variety problems on this same theme here. So now we know that the inner angle there has to be equal to the sum of the intercepted arc measures, or the measures of the intercepted arcs, divided by 2. So now we just multiply both sides by 2. We get 120 is equal to 72 plus x, and subtract 72 from 120, and we get 48 degrees. And there you go. So it's the same concept. We're just plugging in different values into the equation. So let's try number 47. Again, that angle must be equal to the sum of the measures of the intercepted arcs divided by 2, multiply both sides by 2 to get rid of the fraction, and we get 92 is equal to y plus 48, and subtract 48 from both sides, and y is equal to 44 degrees. All right, so why don't you try some of those problems? Try number 48, and when you come back, we'll do it together. All right, we're back. 80 degrees is equal to 54 plus a over 2. Multiply both sides by 2. We get 160 is equal to 54 plus a. Subtract 54 from both sides, and we get 106 degrees. So if you got 106 degrees, good job. Go ahead and try number 49, and when you come back, we'll do it together. All right, we're back. So we know that 111 is equal to the sum of those angles, or those, those arc measures, divided by 2. So multiply both sides by 2, and we get 222 is equal to 58 plus b, and then just subtract 58 from both sides, and we get 164 degrees is equal to b. So if you got that answer, good job. On to segments. So in all the problems that we've done so far, we're dealing with angles in relating to circles. So we talked about, again, inscribed angles, angles where the vertex is on the circle, where it's outside the circle, and where it's inside the circle. And now we're going to, not angles anymore, but now we're going to segments, segment relationships. So the first segment relationship is the secant-segments theorem. So notice that we have two secants. Secant is a segment or a line or something that intersects a circle in two places. And what this theorem tells us is that if you take the whole length of this segment and you multiply it by the external part, the external length, that product is equal to the total length of this segment times the length of the external part. So that's all that means. That's what that says. So again, this length times this length is equal to this length times this length. So you can get a screenshot of that if you want, or a picture with your phone. So we're going to take the total length, and the total length of this, what this is telling us is that this length is 6 and this length is 10. So the total length is going to be the sum of those two. So 10 plus 6, and then we multiply by the external length. So the total length times the external length, and that's going to equal the total length of this segment, which has to be 8 plus x, times the length of the external part, which is 8. So if you see what the pattern is here, you can see it's not that bad. Let me draw that a little better. All right, so now over here we can just do 10 plus 6 is 16. And over here we're going to use distribution. So 8 over here, it's on the right side. Usually we're used to dealing with distribution where it's on the left side, but it's the same thing if you're multiplying your number on the right side. So it's 8 times x and 8 times 8. 8 times 8 is 64, and 8 times x is 8x. Now, again, this is the distribution rule. It's a distributive property. A lot of students are going to not like that, but that's just basic math. That's a basic property that we learned we've done that property quite a bit in my courses. If you're coming from my beginning algebra course, you should definitely recognize that. You may be a little rusty, but you should recognize it. If you're coming from a different course and you haven't seen that, then that's going to be kind of a problem. But again, we're just multiplying 8 into x, and then 8 into 8, and then adding up the result. So now we have to do 6 times 16, which is going to be 96. And then we're going to subtract 64 from both sides. And we get 32. And then we divide both sides by 8, and x is equal to 4. So that's the situation with these problems. All right, let's try one more of these. The total length of that secant is 5 plus x, and I'm going to multiply it by the external length, which is 5, and that product is equal to the total length of the other secant times the external part, which is 6. So here we're going to use distribution. 5 times 5 is 25, and 5 times x is 5x. And then over here we're just going to add those. And we have 10 times 6 is 60. And then we're just going to subtract 25 from both sides. And we get 35 is equal to 5x. Divide both sides by 5, and we get x is equal to 7. So this length here is 7. All right, so it's time for you to try one of those problems. Again, I'll leave the theorem in the window there. If you want to refer back to that, try 52, and when you come back, we'll do it together. All right, we're back. So the sum, or the total length of the top secant times the external length is equal to the total length of the bottom secant, 13 plus 5, times the external length. So using distribution, we have 36 plus 6x, and add those up, and we get 18. And 5 times 18 is going to be 90. And then we just subtract 36 from both sides, and we get 54. And divide both sides by 6, and we get 9. So x is equal to 9. So we got that answer. Good job. Try number 53, and when you come back, we'll do it together. All right, we're back. We're going to take the total length of the top secant and multiply it by the external length, and that product should be equal to the total length of the bottom secant times the external part of the bottom secant. And you can use 2 sets of parentheses if you want on these. It doesn't really matter. You can do that. That's legal. But it's not really necessary, so I'm just going to leave those off. So now we distribute. 5 times 5 is 25. 5 times x is 5x. And then 6 plus 7 is 13. 6 times 13 is 78. Subtract 25 from both sides. And 78 minus 25 is 53. And divide both sides by 5, and we get x is equal to, and you can use a calculator for that if you want, or it's probably not good to leave it as an improper fraction. Usually we don't care. If you get something like 3 over 2, we don't really care if you leave that as an improper fraction. But if you get something like what we just got, 53 over 5, it's probably best to either change that to a decimal, or you can write it as a mixed number. So that would be 10 3/5. All right. So on to the secant-tangent segments theorem. So this theorem is kind of similar to the previous problem, except instead of 2 secants, you see in this theorem we had 2 secant segments. Now we have 1 secant segment and 1 tangent segment. So it's kind of like the angle problems, except now you're dealing with tangents. So go ahead and get a picture of that with your phone or a screenshot with your computer, because you're going to need this. What this tells us is that if you have a tangent segment, and you have a secant segment that are both coming from a common point outside the circle, then the square of this length is equal to the product of the total length and the external part. So if you didn't really understand what that meant, that's okay. We're going to do some practice problems. So you take the secant and you square it, and that square is equal to the product of the total length of the secant, which is 5 plus x, times the external part. That's all that's saying. So 49, or 7 squared is 49. Use distribution. 5 times 5 is 25. 5 times x is 5x. Now we're going to subtract 25 from 49, and we get 24 is equal to 5x. And divide both sides by 5. And again, you can use a calculator if you want and change it to a decimal, however you want to do that. So x is equal to 4.8. Let's try one more of these. So the tangent length squared is equal to the total length of the secant times the external length. So x squared is equal to 4 times 1, which of course is 4. So then x can be plus or minus 4. But we know that a length cannot be a negative number, so that's just going to be, excuse me, that should be 2. I'm going too fast here, so it should be plus or minus 2, but this has to be a positive number, so it's x is equal to 2. Okay, so I'm going to leave those in the window, all that stuff in the window, and try number 56. Hopefully that's not too far for you to read that. And when you come back, we'll do it together. All right, we're back. I'm going to draw that a little bigger, just in case you didn't see that. So the square of the secant length is equal to the product of the total length of the secant times the external part. So 12 squared is 144. You can use your calculator if you want for that one. Distribute, and we get the following equation. Now 144 minus 64 is equal to 80. And divide both sides by 8, and we get x is equal to 10. So if you got 10, good job. Go ahead and try number 57, and when you come back, we'll do it together. All right, we're back. So the square of the tangent is equal to the total length of the secant times the external part. So 9 plus 16 is 25. And 25 times 9 is 225. And if you square root both sides, I didn't mention that you have to square root that, or just ask yourself what number times itself is equal to 225. It's 15. So if you got 15, good job. Now again, it could be plus or minus, but the problem is we can't have a negative length, so it's just going to be positive 15. So we're almost done for the day. We've got one more simple theorem to learn. It's the segment lengths of intersecting chords theorem. So you have two chords in a circle, and they're intersecting. They intersect at this point. And what this theorem tells us is that this length times this length is equal to this length times this length. So pretty simple. Go ahead and get a picture of that with your phone if you want to look at this as we go along here. So 12 times x is equal to 10 times 6. So 12x is equal to 60. Divide both sides by 12, and we get 5. X is equal to 5. So pretty simple, not too bad. 10 times x is equal to 8 times 6, and we get 48 is equal to 10x. Divide both sides by 10, and we get 4.8. And you can leave that as a decimal or a mixed number. I don't really care. Some teachers may prefer one form. So go ahead and try number 60. I'm going to leave the theorem in the window there. And when you come back, we'll do it together. All right, we're back. So 4 times x is equal to 3 times 8. So we have 4x is equal to 24. Divide both sides by 4, and we get x is equal to 6. So if you got that one right, good job. Go ahead and try number 61, and when you come back, we'll do it together. All right, we're back. 4 times x is equal to 6 times 6. So 4x is equal to 36. Divide both sides by 4, and we get x is equal to 9. So if you got that answer, good job. So that's it for today. Don't leave before you get your homework. So a lot of segments and angle relationships in circles. That's what we learned today. So if you want to take screenshots of the work we did to help you with your homework or to study for tests, go ahead and do that now. Here's screenshot number 1, screenshot number 2, screenshot number 3, screenshot number 4, screenshot number 5, screenshot number 6, screenshot number 7, screenshot number 8, and screenshot number 9. So don't go before you get your homework. So here's screenshot number 1. Screenshot number 2. And screenshot number 3. And screenshot number 4 of your homework. Remember, if you don't do that homework completely and correctly and neatly and keep it in order in your binder, this entire course is going to be a 100% waste of your time. So get that homework done, and I'll look forward to seeing you in the next class.